Hello everyone, your friendly neighborhood dev and auditor 0x Gondar here, and today we are going to see how to build an English auction contract in Solidity. First off, what is English auction? It's the basic auction that we know. You put an item at certain price, and if anyone wants, they have to bid a bit higher. Say, well, we are going to build a NFT marketplace, kind of NFT marketplace auction contract. Say the owner puts NFT for at 1 Ether. Alice wants to buy. She says, "Okay, I'm gonna pay 1.5 Ether." Bob wants to buy. Then he has to say, "Okay, I will buy. I will bid 2 Ether." Then if Alice wants to outbid Bob, she has to say, "Okay, I'm gonna bid 2.5 Ether, etc., etc." So we are going to build that. First off, we have a kind of basic NFT contract. I'm not gonna go over it. You can check it yourself. The more important part is auction contract. Our constructor gets initial owner. It's working, right? Yeah. Our constructor gets initial owner, and it passes to ownable. I did this because of deployment and testing purposes. If you check, we have a lengthy testing contract because turns out this very small basic contract is more nuanced than I would uh, assume before building it. And again, as always, this is unaudited. Even though we have lots of tests, it's not 100% coverage. There might be bugs. There are probable bugs in it. I didn't audit it, and I spent like 1.5 hours, maximum maybe 2 hours building the, no, not 2 hours, like one and a half. So fast work, just for education heuristic purposes. Anyway, enough blubbering. Let's go with the auction contract. It's ownable. We have guard pausable. Did I even? Yeah, we have pausable functions too. So we have our auction data. Token ID, seller, starting price, highest bid, highest bidder, duration, start time, end time, minimum bid increment, and a boolean of ended or not. So minimum, like this is pretty self-explanatory. Minimum bid increment is like we pass it um, in create auction, like how much you have to increment in order for it to be acceptable. We have a pending return struct. We are going to see it soon. Like when you get outbid, you are not going to get the amount of money you have put in bidding immediately, but it will be stored in this mapping. We will see why. We have auctions, mapping, events. Again, this is for deployment and testing purposes. Maybe not a very good design, but again, I write fast, and this is not. You shouldn't deploy this code. Let's go. Create auction. This is one of the main functions. Only owner can call this function. It means a new NFT, stores the auction data in the auctions mapping, emits auction created events. You see, it takes a string memory of token URI, starting price, how much the NFT should cost, what is the duration of the auction, what is the minimum bid increment. You see, we mint the NFT here with the token URI, and we are passing the auction data. Seller is the message sender, which is owner. Starting price, highest bid, starting price. Highest bidder address 0 because there are no bidders. Duration, start time now, end time, start now plus duration, minimum bid increment, and that no, it didn't. We put in the auction mapping. auctions mapping. Now we are like we want to buy this NFT, right? So we have to place bid, and it's a payable function because this contract will use Ether native token. So not no USDC, no other token. It's native token Ether, Ethereum, Ether. Um, Anyone can place bids. Bids value must be greater than the highest bid plus minimum bid increment. If the bid is within the 10-minute period before the end time, extend the auction by 10 minutes to prevent sniping. We'll see that just a second. Okay, I'm back. Previous bidder can withdraw their ones via pending returns. What is going on here? Let's see. We are getting the auction with the token ID because we want to bid on a specific auction. We are checking if the auction exists or not, ended or not. Yes, and here we are checking the message value, which is the amount of that is being put into this payable function. It should be minimum highest bid plus minimum bid increment. Okay, now here we are doing this. If uh, like just a second. Yeah, sorry for all these pauses. Now, the reason why I put this block here, what it does is if now when the function is called is within the time amount of 10 minutes before the auction end time, we are extending the auction end time by 10 minutes. Why? Because we don't want anyone to snipe the NFT. Imagine the situation. There is bidding going on. Alice bids 1 Ether, Bob bids 2 Ether, Alice bids 3 Ether, etc. etc. Then Bob waits for the very last block, very last second to outbid Alice, so that Alice cannot, she won't have the time to outbid Bob, and Bob will win the NFT maliciously. We don't want that. So we are extending the time by 10 minutes each time the time period is small. This will ensure that like there will be enough time for anyone who wants to bid again, and if like they can afford it, they can bid. If they cannot, like if let's say the NFT starts to cost too much, maybe 10 it, maybe 20 it, and like the outbid person says, okay, no, I'm not gonna pay it. Let the person, let the highest bidder get it. We have a note here. Well, what are we doing? Well, um, hmm. So first, let's see what we are doing here. Then let's go back to the note. So we are checking if the highest bidder is not address 0, then uh, remember we talked about the pending returns. We are incrementing the highest bidder of highest bidder's amount with the highest bid. What's going on here? Which means that Alice and Bob were in a bidding wars. If Bob bid higher than Alice, let's say Alice bid 1 Ether, Bob bid 2 Ether, Alice had put money because it's a payable function into the contract, and now since Bob is the highest bidder, Alice has to get her et back. So we are doing this here, and why we are not doing this, you see in the commented out section, uh, we are transferring the amount to the previous highest bidder. There are two problems with this approach. First, you shouldn't use transfer uh, with native token because transfer will only take 2300 gas, which is not enough for complicated actions that are done in receive or fallback function. If the highest bidder was a smart contract, which means this function will fail and will be DOSed due to out of gas, which means uh, like Alice, if she doesn't want anyone to outbid her, and if we use this code, she will just make some complicated operations in her in the contract, smart contract that she used to bid in the receive function of that contract, that it will revert due to out of gas excuse me, error in transfer function. So she couldn't be outbid, and like that wouldn't work, like if you cannot outbid someone, they will win the auction maliciously without engaging in the auction. They can pay the minimum amount and they can win. And you can yeah. And the second is, you most of the time pretty much never use the push method, but you use the pull method. Push method is, right now we are sending the tokens directly to Alice. What if the highest bidder, previous highest bidder Alice, reverts again with out of gas or with another method, reverts, and we cannot send the token, we cannot not to, yeah, token, we cannot send the native token or token back, which means she cannot be outbid, because anytime someone else tries to bid, the function will revert fail, so Alice will win the auction maliciously. Hence we are not doing this, we are doing this pull method, not push method. Don't do push method, do pull method. Okay, so this was the complicated part. Then we are putting the high speed as the I'm recording, right? Yeah, as message. Just a second. Yeah, I was checking whether I was recording or not. We are putting the message will as the highest bit, and highest bidder is the message sender, the person who called this function. I know this was complicated, but play around it, you will see. This is more like security oriented development. We have to know about this stuff. Imagine like if we were using USDC. This is a very well known bug. If USDC has a, like if we were not using native token but USDC for bidding, USDC has a blacklisting functionality. What can happen? Because anything can happen. Alice can bid for this NFT, and after she bids, she can, like, in theory, can get blacklisted by USDC, which means she cannot receive the amount of USDC she put back, which means again anyone cannot outbid her, because each time they try to bid, the push method will fail, revert, and Alice will win the NFT auction maliciously. Okay, let's go to end auction. Anyone can call this function, but only after the end time has been, only after auction has ended. We will see why anyone can call. Here, if the highest bidder is address 0, which means no one has bid for the NFT, then we are burning it. We are getting the highest bid. Again, we are checking if the highest bidder is not address 0, then we are sending the highest bid amount, which is the amount that the winner has put, to the owner, to the seller. We can do that because we are the seller. We can do the push method here, I guess. Again, I didn't really audit, I just focused on that part. But again, you see, we are using low level call method. We should always use this, we should never use transfer, etc. Cancel auction can only be called by the owner. Auction has to exist if there are bidders, which means that highest bidder is not address 0, then You cannot cancel, we cannot cancel. Like the owner doesn't have full power here. If someone started to bid, owner cannot cancel. And if no one has bid, and like auction ended and we burn the NFT. Now you see we have the withdraw pending returns function, which is for when I bid as a user, I bid in the auction, but someone outbid me. Now they are going to win, and I don't want to bid again. I just want to, like, it's too much. Like, I bid 5 at, they bid 10 at, 15 at. I don't want to pay 16 at or more. I just want to take my money back. This is what I do. Remember, we put it here, pending returns. We do that here. Auction has to exist. Message sender has to be. Um, Message sender cannot be the highest bidder. This is the design choice that I made. If you are the highest bidder, you cannot withdraw your pending returns. Don't have pending returns. Um, Again, I'm not sure about this part. I wrote extensive tests, but not too much. Again, I spent maximum 1 to 2 hours writing these contracts, so they might be infested with bugs. Even though I'm a security researcher, like I cannot audit my own code because of tunnel vision and assumptions that I make in writing. Again, these contracts are for heuristic purposes. Audit it yourself. Tell me the bugs that are present. Um, we are getting dependent returns of the caller, and we get the value. We turn it to 0. We nullify it, and then we send it to the um, message sender. So we don't owe them anything. Just a second. Yeah, okay. Sorry for all these pauses. I'm getting sick and my throat hurts, hence all those pauses. Claim NFT. The winner should be able to claim NFT. Again, this is a design choice. You see, when we end the auction, the seller gets the money, but the winner doesn't get NFT. Again, this is a design choice I made. It might be bad, it might not be bad. You can choose something else. Uh, this is how I did it. It seems to be working. Um, in order to claim an NFT, you pass the token ID. We are checking whether you are the highest bidder for the token ID, and if so, uh, you get the NFT from this contract. We have getter functions, and we have a getter get remaining time. Uh, you see, we have a little comment here, and that's pretty much it. Again, maybe in this contract, after watching the tutorial, you might want to look at the test file, because you see it's almost 500 lines of code, and it's like the double the contract itself. Because of these little things, this is a like not complicated but nuanced contract, and it might contain some bugs, some inconsistencies, etc. So we are tasting that. Just a second. Yeah, that's pretty much it. This is how you could build an NFT marketplace slash English auction. There's another type of auction, Dutch auction. Maybe I will show that later on. It's basically um, you give a as a seller, you give an amount, let's say 10 ether. 10 ETH, you start the NFT auction with 10 ETH, and as the time progresses, the value decreases to 9 ETH, 8 ETH, etc. And the first person who buys at that decrease in value gets the wins the auction. It's an interesting, it's a different kind of approach. So this was it. I hope you enjoyed it. Again, sorry for my voice. I'm getting ill. You will find the code uh, in the description to the GitHub repo. Um, yeah, that's pretty much it. Thank you for your time. All the best.